Hey guys, this is Sunny from Air Inspect here. So in the last video and the video before, Patrick had walked you through some of the settings for DJI Air 3 as well as some of the capture technique. So now that we have flown the drone and have captured a slew of photo data, now let's move on to processing it. So here, as you can see, we have the data that is captured by Patrick. Now, what we need to do first is start a new project on iTwinCaptureModeler and import the photos. So here's how we do that. First off, launch iTwinCaptureModeler master. And as good practice, launch the engine as well. You can launch that before starting the AT, but generally we have the engine on by default. So let's start with creating a new project. So let's start with test. Data. Roof. So now that we open a new project, this is what we see. So to start, let's create a new block. So a block is the fundamental block, so to speak, in the processing workflow. And here we'll be doing subsequently aerial triangulation, reconstructions, and so forth. So whenever we say block, just refer to as this creating a new block or copying a block. So now that we're in overview, you can see there are no photos, no photo groups, and there's also no megapixels because we haven't input any data. So let's do that. So I'm going to go into photo and add photo. Here you have two options, add photo selection and add entire directories. So let's check out add photo selection first. So here we go into the images and we go into the test data and we find the same folder that we were just looking at, and these are the nadir or vertical data that Patrick has captured. So here you can import a singular picture, which wouldn't be realistic. You want to import an entire directory. So here we're going to select all and click open, and then we have it. We have the pictures. There's a quicker way to do this, and that is to add entire directory. So we're going to delete this photo group. Now when you delete photo groups in iTwinCaptureModeler, it's not going to delete the pictures themselves. It's just going to remove them from the pool of data that it has. So let's add entire directory instead. Here we go to images, Air 3, select folder. When you have subdirectories inside a folder as well, it's going to ask you if you want to include the subdirectories as well, which usually you would click yes. So here we have the photo. Let's go back to overview. We can see that there are 206 photos in one single photo groups and 7.5 gigapixels. Now to check, let's go into 3D view. Here we can see these blue dots, series of blue dots, as well as an orientation. So each of these blue dots represents a data point. As you zoom in, you can see the data points themselves. It's a brief representation of its orientation. And by pressing spacebar, you can actually navigate to the particular pictures that you captured. So we can see that even in a consumer drone, DJI Air 3, the accuracy is actually enough that you can have a rough position reference of where the data is captured. So now that we have photos imported, let's go ahead and conduct an aerial triangulation process. So we're going to start by clicking Submit Aerial Triangulation. Process with iTwinCaptureModeler engine. So make sure you have an engine active. So let's click that. Here you get an option to input a name for the output block. So whenever you submit an aerial triangulation process, it's going to create a new block, and it's usually going to be called block 1 AT, or you can name it something else. We can say first roof process. And now we move on to 2 of the 3 tabs that is very much crucial for the entire process. Here we have positioning and georeferencing. Choose how the aerial triangulation should adjust and orient the block. So above here we have adjustment constraint. So adjustment constraints are used when you have very accurate data. What do we mean by that? So this means data that is within 5 centimeters margin of error. Here we have control points, photo positioning metadata, and point cloud scans. Control points and photo positioning metadata are most often used, especially for control points in terms of enterprise work. So since it's a DJI Air 3, the margin of error is not within the tolerance for any of these adjustment constraints to be used. So we won't check any of these boxes. Second, we have final rigid registration. So these are meant for data that are not as accurate. So here we can see select an optional rigid registration to perform after scene solving. It will override scene coordinate system. So this means that after processing the aerial triangulation, the engine is going to rigidly register the block into the positioning metadata and so forth. So what do we mean by this? So in terms of the process, any data that is beyond a 10 centimeters margin of errors, you want to keep this option checked. So in this case, photo positioning metadata, where we don't really have a high confidence in terms of the accuracy of Air 3. Even though in a 3D preview, we see each data point and they are roughly aligned, we don't really want to take that chance. And usually final registration for photo positioning metadata are always on by default. And when we have ground control points in enterprise work, we'll check control points with final registration on. If you don't have any constraint, or if you only have one constraint, for example, if we have photo positioning metadata on as a constraint, it will still run a rigid registration when you have only one constraint regardless. So in this case, for most of your drone capturing work, final rigid registration for photo positioning metadata are almost always on. Next, let's move on to settings. Here we have poses and tie points. So select the policies and computation settings used by the aerial triangulation to estimate the poses of the photos and tie points. So here we have compute and adjust. And we can see at the bottom right here is that adjusting poses is advised with proper initial position and rotation information. So it means that if you have a high confidence of your data, you should just click adjust, since it is accurate enough that all the engine really needs to do is to nudge it here and there and to make small adjustments, so to speak, so that it won't have to expend a tremendous amount of time to compute everything. But in this case, since we are processing low confidence data, we're going to use compute instead. In the advanced tab, there's also key point density. How many key points do they want to do you want the engine to extract from each pictures? But the problem with this is that as the project gets bigger, if you choose the high key point density option, it's going to significantly slow the process. You can also see compute for position or adjust, rotation, tie point. The compute is always on by default for tie points, but for rotation and position, if you want to specify a specific thing to adjust or compute for, you can do that. But in key point density, for small project, we could click high. but generally default is good enough unless you're troubleshooting. There's also pair selection mode, but this is more for very exceptional cases. So in this case, we'll leave it on for default. Optical parameters. This is generally pre-calibration stage enabled for cameras. Sometimes it's what this used for is the focal length and the distortion of your camera is going to, the engine is going to take that into account. So in this case, the DJI Air 3, the camera that it uses is actually within the database. So that's how in the photo group, let's exit right here, and that's why in the photo group it actually recognized the camera DJI FC8282. If it doesn't recognize the camera within its existing database, it will tell you, and in this case you should help it to identify, because otherwise you're going to encounter some problems. So let's go back to the tab. I'm going to rename it again, Roof AT instead, and we'll check here, final registration for photo positioning metadata, and we're going to choose compute. Adjust main parameter, lock all parameters, almost always adjust main parameters. Target extraction, there is no QR code, April tags, or chili tags so forth, so we're going to leave it as none. Automatic color correction, so here you have a few options. So you have none, blockwise, and machine learning. So when you're capturing, the lighting condition may change, and that might shift the color in the picture, and that might throw off your data. So the machine learning color correction will correct the color of what it sees is the most appropriate, and then it will adjust the color. But if you have a very uniform lighting, then you can choose blockwise or none for that matter. However, if you have any hard lights and hard shadows and stuff, this might cause problem in your output. So generally we leave machine learning on, but sometimes it might leave the color to be too vibrant, but generally for deliverables it's not, it doesn't really play into that big of an issue. Splats, so after it runs an AT, it will create a splats for you to view, a rough shape of what the mesh would be. In most cases, we leave it on. It doesn't really take that long, especially for computers to powerful computers to crank out a splats after running AT. So now that we have all the settings in place, go ahead and double check everything. And then we're going to click submit. So you see aerial triangulation pending, and submit it and waiting to be processed. And here we can see the engine kicks in. Info, task complete, starting task job. So now we can see that this process is running. Aerial triangulation, job details. Now it shows you a few milestones in this entire process. And we're going to click into view settings. So here, aerial triangulation settings, positioning, georeference, none. So this is for viewing your, this is for viewing the settings you have for this AT. So in case you need to backtrack and see what settings you ran for a specific AT, you can do that. So for the sake of time, I'm going to cancel this and I'll bring you to a different project that I have run with the data, and we'll show what it will look like as a result. So here it is. So we have block 1, 3D view, and let's go to block 1 AT. So this is what the output will look like. Here we can see the splats, but before we proceed, let's have a look at the overview. We can see complete data. The block is ready for reconstruction, photo positioning level, georeference. Now this is actually very good and surprising for DJI Air 3 because what this positioning level mean is that if we are to reconstruct a mesh from this AT is going to be georeference. That means if you put it down on a particular viewer online that would look at the georeference data, it will actually show up where the location it is captured. And in enterprise cases, it will also be properly aligned vertically, horizontally, orientation wise. It will so it will look like as if it was there. So in terms of output wise from Air 3, this is actually very good. So here we see 206 photos, 7.5 gigapixels. And let's have a look at settings. Here we have adjustment constraint none, final registration, photo positioning metadata like we just showed. And let's move on to estimation policy, tie points, compute. So we ran this on the compute. Adjust main parameters, so you can see the focal length, principal point, distortion, all of these are adjusted. So let's say you finish the aero triangulation process, and this is what you're looking at. Now let's zoom in and have a look at the splash. We can see that since this is a vertical nadir, all of these data are nadir, that essentially what it did, if we were to briefly recreate what the drone sees, is vertical shots of the roof. So in the splat preview, what we can actually see that there are some data missing because the roof essentially covered the side of the house. But now that we have a complete AT, let's move on to reconstruction. So here, to start a reconstruction, we're going to click New Reconstruction, 3D Reconstruction. So here we can see we already have a demonstration reconstruction 1 model, but I'm going to run you through how to create this reconstruction. So here, reconstruction tool 2, we can see ready for production. You can define reconstruction layout and settings for a spatial framework and process setting tabs. So let's go to spatial framework. So here we can see a few tabs. Here we have a preview, and on the right side you have spatial reference system, SRS, and tiling. Now tiling is the first thing you want to change. Now here we have no tiling. For a smaller model like this, that might not be an issue, but when you go into bigger models, no tiling will cause a significant lag in your hardware that will cause a lot of issues. So we can click the drop down menu and we'll choose adaptive tiling. So what this will do is it will calculate the detail of the mesh and splice it up into different tiles, and roughly they will use the same amount of RAM usage. Here we have target RAM usage 16. You can lower this number as well, and this will in turn make the tile more numerous, but it will also sometimes slow the process a bit. As when we kick into production, you'll see that the production is going tile by tile. So if you do splice it up into too much tile, it could cause the process to be slower than it would be. So here, let's move on to spatial reference system. So here we have default WGS84. So this is the default spatial reference system for DJI drones. But for references in for proper georeference reality models, we want to choose a more appropriate spatial reference system. In the case of this capture, it will be GDA 2020 MGA Zone 55. So let's go ahead and do that. 55. Okay. So now that we have this finish, processing settings, this generally is untouched unless you want to adjust certain things. We have fill small holes only, or fill all holes except at tile boundaries. We can do that. Geometric simplification, we have standard, planar, Color correction. Here you can make another adjustment. If you chose automatic, you can choose standard or none. But let's leave this as default. Double check your spatial reference system. Always double check your spatial reference system, especially for enterprise work. And then we're going to click Submit Production. So now we go into the Production tab. So we have Production 1. We can name this Roof 1. And purpose, Export 3D Mesh. We have a few more options, but in this video we won't cover them. Format options, Bentley Scalable Mesh. This is generally a very good default output, but you can also choose Legacy 3MX, and that might give you a few more things to play with. Quality, such as the texture compression as well. But generally, Bentley Scalable Mesh is more than enough. Remember to generate level of detail across tiles. And then if you're uploading it, generate web-ready scalable mesh as well. Here you will get another window for your spatial reference system. Make sure you choose the appropriate one. This is for if you want your production to be a different spatial reference, spatially referenced differently compared to your reconstruction. But generally you want to match as both. Extent, here you can choose what tile to produce. So here we can see all tiles are highlighted white. But if I want to, I can select one tile, or I can hold down Control to select multiple tile. This is good for testing out a certain production. In really big projects, you can say if this is a ginormous warehouse and it would take days to process the entire mesh, I can choose, say, 3 to 4 tiles of the warehouse where I think it might be problematic, and I could run the production, and it will only take maybe an hour to crank out these 4 tiles, and I can see if there are blemishes on them, and if there are not, I could then go ahead with a bigger production. If there is, it saves me a lot of time because I won't waste days on producing a model that won't look good. So let's go back, let's discard the changes so that we can see all 17 tiles are selected. And then we also have the destination here. You can choose a specific directory if you like. And then we're going to click Submit. And then you will see here, Roof 1. The production has been submitted and is pending. And now, we can look at the engine. We can see starting task job, test data, Roof 1. So we'll go ahead and cancel that because we already have a production ready. So after your production is submitted, here's what it will roughly look like. Overview, completed, the production is complete. You can see this took 1 hour and 5 minutes. So even for a small house, this could take significant time. So you really want to make sure that you have adjusted all the settings correctly so that you won't waste any time. We can see the settings. So here you can see the settings, format 3SM, the destination, texture maps, visible colors, compression quality, 75%, texture sharpening, adaptive tree, that's the level of detail, web-ready scalable mesh, it's false, and the spatial reference system right here. So let's have a look at the result. So here's what we have. We can see that the roof is rendered quite beautifully, and we can zoom in and have a look at some of these details as well. So even for 206 pictures, which in industry standard really is not a lot of pictures at all, we can still see that there is a great level of detail that the capture managed to bring out. But since this is a nadir only capture, we can see some of the problems. Namely here, we can see that the roof, because it obscured the side of the building, and also because this is a nadir shot, it won't be able to pick up details such as these beneath the roof. We can see here in the front of the house as well, there isn't any particular detail that it managed to reconstruct. Because the data is simply not there. There are no pictures or simply not enough picture to cover these. So that brings us back to the previous video where there are captures done at an angle. We call it oblique, or in more casual terms, you can call it just capture at an angle. So we saw that Patrick have done additional captures at an angle, at oblique capture, so to speak, to capture more details of the house. So let's go back to the previous project, and we're going to include that into the existing project, or we can create a new block with the included data as well. So let's do that. So let's create a new block. Here in Photos, you can click Add Photos, Add Entire Directories. We go back to Test Data. Let's bring in Air 3. So here we have the original nadir capture right here. And we're going to bring in the oblique capture as well. So let's go back, Test Data, here. Select Folder. Do you want to include subdirectories? In this case, we'll click Yes. Okay, so now we have the subdirectory ready. Now let's go back to the preview. You can see something interesting happen here in the 3D preview, is that the captures of the oblique capture doesn't necessarily line up vertically with our nadir capture. The reason why is because the z-axis offset is inconsistent. There are ways to fix this manually, but in enterprise drone this generally won't be an issue because we have RTK. But in the case of the Air 3, this has become an issue. So we can still run a process regardless, but if you really want to bring these data points up manually, you can do so. Here you can select one of the data point, and you can right click, Properties, and Poses. Here you can see you can edit the spatial reference system, longitude, latitude, and height. So you could actually bring the height up if you want to. But what this means is that you'll have to do it with each individual data points. So in this cases, we're just going to run the process. So let's go ahead and submit aerial triangulation. Block 3, let's say roof with both picture. Roof with both picture groups. Positioning and georeferencing. Final rigid registration is on positioning, photo positioning metadata. Here in settings, we will move it to compute and adjust main parameters. And now we'll submit it. So let's go back to see what that will look like. Here we have that. Incomplete photos. You can estimate missing photos information by aerial triangulation. So after you run an AT, this is what it will look like. Complete data. The block is ready for reconstruction. Photo positioning level, relative. It is different than the last one. So here we can see that the positioning level is relative instead of georeference. So what does that mean is that although it has finished aerial triangulation and for a reconstruction of a reality model, it is unable to georeference it. So this is likely caused by the fact that there is a split between the oblique and the nadir capture, especially in terms of height. So if you are really dead set on having georeference, you can always manually bring each data point up But you can see that for bigger projects, this becomes impossible in terms of practicality and time. So let's say you have finished a process. So you can see that the engine has brought the nadir and oblique together and aligned. So immediately off of the splash, we can off of the splat, we can see that there are more detail that the additional data has bring out. So here we can see these angles, including the side of the house as well. So we're going to go ahead and create a new reconstruction, following the same settings we have before. Tiling, adaptive tiling. You'll notice that because this model is relative instead of georeference, there isn't any spatial reference system that you could select. That's because there is no spatial reference georeference for this reality model at all. One thing we can also touch on is the boundaries for the process. So you can choose box or polygon. In this case, you can kind of set and cut where you want the reality model to reconstruct, the engine to reconstruct, so to speak. You can accept changes, and here we shrink it down, and this can kind of reduce necessary cleanup after your reconstruction and production. But let's go ahead and reset that back to default and accept, and let's submit a new production. Production 1, roof with more detail. Purpose, export 3D mesh. Format options, 3SM. Level of detail, no spatial reference system because this is a relative model. Extent, we're going to leave it. Destination, we're going to leave it. And submit production. Here we are. Generally it would just start running, but if you're really unsure, you can always keep an eye on the engine, because the engine will show you that it has started the task. But usually it will start in a very timely manner. Here we see the milestone, 27 tiles to be produced, running process time. We're going to stop that as we already have a production ready for demonstration. So here we have the results. Immediately, like we see on the splats, far more details on the side of the house compared to the last one. Especially here. Here, it's just a complete hole in the previous oblique only data. Let's go back to the previous data just for a reference. Here's what it looked like with oblique or vertical only. And here is what it looks like with the additional angled here's what it looks like with the additional oblique capture as well. So this is nadir only, and this is nadir with oblique. There we go. So not too bad. Here we can also see Patrick. A very rough shape of him. So we can really see that despite not being an enterprise equipment, Air 3 is capable of capturing data for aerial triangulation. In fact, the technique that Patrick have taught you with the nadir and oblique is very much used in enterprise capture as well. Obviously, for enterprise equipment, we have far more in-depth techniques and curriculums for enterprise capture. We do have them on our course, but Patrick have taught you very good fundamentals on that. Verticals are good and expedient, but if you want more detail, you'll need to go at an angle and capture some oblique data as well to go along with your nadir data in order to maximize your quality of output. So that's going to be it for processing data from the DJI Air 3. We learned that despite being a consumer drone, it is still very much capable as a capture drone for reality modeling. That's going to be it for this video. I'll see you in the future. This is Sunny from AirInspect signing out.